This is the V-1 flying bomb, also known as the Doodlebug or buzz bomb, the world's first operational cruise missile and one of the earliest unmanned weapons in history. Developed by Nazi Germany's Fiesler Aircraft Company under the designation FI-103 during World War II, it was not designed to win the war, but to spread fear as a devastating psychological weapon. Approximately 20,000 people died while manufacturing these missiles at the Middlework underground factory. Ironically, more people died building the V weapons than were actually killed by the weapons themselves in the UK. In this animation, we will explain how the V-1 flying bomb worked, including its engine, fuel system, guidance mechanism, and warhead, and how all these systems operated together in flight. It measured 7.3 meters in length, stood about 1.42 meters high, and had a wingspan of 5.3 meters. To imagine its real size, compare it with a Toyota pickup truck. A typical Toyota pickup truck is around 5.3 meters long. The V1 was almost 2 meters longer than the Toyota pickup truck. The body was made of steel, tough but light, perfect for fast production and flight. At the very tip of the nose is a small propeller, the odometer. It counts the rotations to measure how far the missile has flown. After launch, after covering a distance of approximately 35 to 40 miles, it sends an electrical signal. After that, 2 fuses located in the upper section of the bomb become activated. For safety reasons, they were not armed at the time of launch. Its second important function is to bring the counter unit located in the rear section of the bomb to 0. When the counter unit reaches 0, it means that the V-1 has arrived above its target. The buzzing sound stops, and the engine shuts down. The elevator is pushed downward, and the missile goes directly into a terminal dive and crashes toward the ground, detonates on impact. The accuracy of the V-1 were very poor, about 1 kilometer square, but today's modern missiles are 1 meter accurate. Inside the nose cone is a magnetic compass. Since there was no GPS in 1940, the compass helped the missile flying in a straight line. If the missile deviated from its course, the compass sent a signal to the master gyro. The master gyro would then activate the servo motors. The servo motors manipulate the rudder and elevator to correct the missile's course and maintain its direction. Behind this section is the warhead, containing around 1,800 pounds of high explosive. On the top of the warhead section, there are detonation fuses designed to ensure that the 850-kilogram, 1,870-pound Amatol warhead detonates upon impact. If the V-1 were to suffer a malfunction or mechanical failure and perform a belly landing instead of diving directly into the target, a belly-mounted switch was installed underneath the missile. In the event of a belly landing, this switch would trigger the detonation system, ensuring the warhead still exploded. And this is the fuel tank, which had a capacity of 160 gallons. The V-1 used ordinary fuel. Since it was designed to be used only once, it did not require the special, expensive aviation fuel used in aircraft. With 160 gallons of fuel, the V-1 had a range of about 150 miles. With the same amount of fuel, a Toyota Hilux can travel more than 2,500 miles. In fact, with that average, you could travel from Berlin to Istanbul and back, which is roughly 1,250 miles in total. There are 2 spherical air tanks tightly wrapped with steel wires to increase their strength. These wires help reinforce the tanks and prevent them from bursting under such high pressure. The front air tank is used to pressurize the fuel tank. Due to this pressure, the fuel flows through the fuel line and reaches the engine. The second air tank is used to operate other systems on the missile, such as the master gyro and servo motors, which we will discuss later. There is a 30-watt battery. It powers the systems on the V1 and is also used to arm the fuses. The fuel filter, because the V1 used compressed air rather than a mechanical pump. Due to simplicity and reliability, even a small particle of rust or dirt from the tank could cause catastrophic engine failure. The filter ensured a consistent, clean flow of fuel, which was essential for maintaining the engine's rapid combustion cycle of 50 times per second. On the top is a pitot tube. It is used to measure airspeed and provides data to the autopilot system, which uses a combination of gyroscopes and compressed air to maintain altitude, typically between 3,000 and 4,000 feet. On top of the engine is the ignition plug. It initiates the engine and is used only once. Like most pulsejet engines, a single ignition is enough to start the cycle. Before launch, a ground-based starter system is used to bring the engine to life. The Escania Flight Control Automatic Guidance System, which pilots the V1, can be considered the brain of the missile. It receives directional information from a magnetic compass and makes small adjustments using magnets within the guidance system to correct the flight path and keep the missile on course. These tiny corrections, guided by the magnetic compass, are transmitted to the control surfaces through a mechanical servo system. As a result, the missile continuously makes slight adjustments to its rudder and elevator, ensuring it stays on the correct path and accurately reaches its target before detonating the bomb. These are the servo motors. Their job is to control and maintain the direction and altitude of the V1 missile using the rudder and elevator. The right side servo controls the rudder. When it moves backward, the missile turns to the left, and when it moves forward, the missile turns to the right. The left side servo controls the missile's pitch. When it moves backward, the missile descends, and when it moves forward, the missile climbs. Now let's move on to the engine, which is also the reason why the V1 is sometimes called the buzz bomb. The engine is a tube-shaped Argus 104-109 pulsejet, approximately 3.7 meters long, capable of producing around 660 pounds of thrust. This allowed the V1 to fly at speeds of about 400 miles per hour, 640 kilometers per hour, at altitudes between 2,000 and 3,000 feet. The internal machinery of the engine was very simple. Fuel lines and an air valve sprayed fuel into the engine, followed by a shutter valve at the front. When the shutter opens, air and fuel enter the engine together. A spark from the engine plug ignites the mixture, creating an explosion. The force of the explosion closes the shutter, and then it opens again, letting in air and fuel for the next explosion. This cycle repeats approximately 50 times per second. This produces a distinct roaring sound, often reaching 140 to 150 decibels, which is louder than a jet engine at takeoff.